Ancient ideas about matter. 1. Indian philosophers, around 500 BCE, Maharishi Kant suggested that matter, Padarth, could be divided into smaller and smaller particles until a stage was reached where further division was impossible. 1. These smallest indivisible units were termed Parmanu. 1. Pagoda Katayama expanded this by stating that these indivisible particles combine in different ways to form all matter. 2. Greek philosophers, around the same time, Democritus and Leucippus in Greece proposed a similar idea. 2. They called the indivisible particles atoms, from the Greek word atomos, meaning indivisible. 3. These ideas were philosophical and lacked experimental proof until much later. Laws of chemical combination. Law of conservation of mass, Antoine Lavoisier. This law states that the total mass of reactants is equal to the total mass of products in a chemical reaction. Mass is neither created nor destroyed. 1. For example, when 10 grams of calcium carbonate decomposes, it produces 5.6 grams of calcium oxide and 4.4 grams of carbon dioxide. 1. The total mass remains constant, 10 grams. Law of constant proportions, Joseph Proust. In any pure chemical compound, the elements are always combined in a fixed ratio by mass, regardless of the source or preparation method. 1. For example, water, hydrogen hydroxide _2O always contains hydrogen and oxygen in an 8:1 mass ratio. 1. Similarly, ammonia, New Hampshire 3NH_3 New Hampshire 3, always has nitrogen and hydrogen in a 14:3 ratio. Dalton's atomic theory. John Dalton developed the first scientific theory about atoms in 1808 to explain these laws. His key postulates were: 1. Matter consists of tiny particles called atoms. 2. Atoms are indivisible and indestructible during chemical reactions. 3. All atoms of a specific element have the same mass and chemical properties. 4. Atoms of different elements have different masses and chemical properties. 5. Atoms combine in simple whole number ratios to form compounds, e.g., water is H2OH_2O2O, a 2:1 ratio. 6. Atoms in a compound are always present in the same proportion. Dalton's theory laid the groundwork for modern chemistry but has since been refined. For example, atoms are now known to be divisible into protons, neutrons, and electrons. Atoms and their properties. 1. Size of atoms. Atoms are extremely small. 1. For instance, the radius of a hydrogen atom is approximately 10⁻10 carat, 10 meters, 0.1 nanometers. 1. Millions of atoms stacked together would form a layer as thin as paper. 2. Symbols of atoms. Dalton was the first to assign symbols to elements. Later, the modern system used one or two letters from the element's name, e.g., H for hydrogen, Na for sodium. Some symbols are derived from Latin names, e.g., Fe for iron, from ferrum. Atomic mass. 1. Atomic mass is the relative mass of an atom compared to 1/12 the mass of a carbon-12 atom. 2. Initially, oxygen was used as the standard, but carbon-12 was later chosen for its universality. 3. For example, hydrogen's atomic mass is approximately 1 U, unified atomic mass unit. Oxygen's atomic mass is 16 U, molecules and icons molecules, groups of 2 or more atoms bonded together. 1. Examples: molecules of elements, O2O_2O2, oxygen, P4P_4P4, phosphorus. Molecules of compounds, hydrogen hydroxide _2OH2O, water, CO2CO_2CO2, carbon dioxide. 2. Molecules can be monoatomic, e.g., He, diatomic, e.g., O2O_2O2, or polyatomic, e.g., S8S_8S8. Icons, atoms or groups of atoms with a net charge. 1. Cations, positively charged, e.g., Na plus carat plus plus, Ca2 plus carat, 2 plus, 2 plus. 2. Anions, negatively charged, e.g., Cl minus carat minus, COVALENTS 1042 minus underscore 4 caret 2 42 minus. 3. Polyatomic ions. Charged groups of atoms, e.g., NH4 plus NH underscore 4 caret plus NH4 plus CO32 minus CO underscore 3 caret 2 CO32 minus. Chemical formulae. 1. A chemical formula represents the composition of a compound. For example, water, hydrogen hydroxide underscore 2OHio2O, has 2 hydrogen atoms and 1 oxygen atom. 2. Determined using valency, combining capacity of an element. Example, calcium chloride underscore 2 calcium chloride, combines 1 calcium ion, Ca2 plus Ca caret, 2 plus, Ca2 plus, with 2 chloride ions, Cl minus Cl caret Cl minus. Molecular mass and formula unit mass. 1. Molecular mass, the sum of the atomic masses of all atoms in a molecule. Example, water, hydrogen hydroxide underscore 2OHio2O, equals 2 times 1 plus 16 equals 182, times 1 plus 16 equals 182 times 1 plus 16 equals 18U. 2. Formula unit mass, similar to molecular mass but used for ionic compounds. Example, sodium chloride, Nakal NaClNaCl, equals 23 plus 35.5 equals 58.523 plus 35.5 equals 58.523 plus 35.5 equals 58.5 U. Mole concept. 1. Definition. 1 mole of any substance contains 6.022 times 1023 times 10 caret 23, 6.022 times 1023 particles, Avogadro's number. 2. Mass of 1 mole. The molar mass of a substance, in grams, equals its molecular or atomic mass, in U. Example, 1 mole of oxygen, O2O underscore 2O2, weighs 32 grams. 3. Applications. Allows chemists to relate the mass of substances to the number of atoms or molecules in a reaction. Example, in the reaction 2H2 plus O2 right pointing arrow 2H2O2H underscore 2 plus O underscore 2 right pointing arrow 2H underscore 2O2H2 plus O2 2H2O, 4 grams of hydrogen reacts with 32 grams of oxygen to produce 36 grams of water.